Friends, in this new chapter, the previous video, we talked about the evolution of the hydraulic excavators. Now I will be talking about the basics of the hydraulics because it is very important to understand the working of the hydraulic excavators. Hydraulics, the subject, deals with the machines works with the fluids, that is power transmission through the fluids. Blaise Pascal from France, a mathematician and a physicist, invented a fluid law called as the Pascal's law. What is the Pascal's law says? Whenever we apply a pressure at one point of the liquid, the pressure is equally transmits in all the directions of the fluid. Suppose this is a ball having water inside. If you press at one point with the thumb, the water comes with equal velocity in all directions wherever the holes are provided. Let us see this figure. The formula, simple formula for the Pascal's law is the force is equivalent to the pressure and area. This is the example. Suppose let us take two cylinders, one with narrow diameter, the other with the larger diameter. Both are connected through a common tube and filled with the liquid or water. Suppose in the smaller diameter barrel, 1 square inch piston is available here. The larger diameter is 100 square inches piston. So what happens here? If you apply, that is force, F 1 lb here, it transmits into the 100 lb's output. What is the difference here? The difference is the diameter. So if you apply 1 pound pressure on this smaller diameter piston, the power is transmitted through the liquid and we will get the output of lifting 100 lb's because this particular surface is 100 times more than this surface. Why? Because this pressure is constant, both sides. F1 is equal to the pressure is whatever is available here into area. Here F2 is equal to, as the area is multiplied to 100 times, the output also increases to 100 times. Okay. Pressure at a point in a fluid is equal in all directions. Let us see this figure also. This is most important. What is the difference here? We could able to lift the 100 pounds by just applying 1 pound pressure. That is by increasing the surface area. But what about the travel distance? So here F is equal to the pressure into area because the pressure is uniform throughout the container. Because the area is increased here to 100 times, the output force also is increasing to 100 times. Whereas distance is reduced by 1 by 100th time. If it moves here 100 millimeters, it moves only here 1 millimeter. So this one, F1 into D1. This F1 into distance 1 is equivalent to the, you see here, larger diameter piston is moved only very small amount. Okay. Again, F2 is equal to A2 by A1. All this formula we can make whatever way we want to require. You want to decide the distance of travel, or you want to distance amount of the load to be lifted through this cylinder, that we have to decide with this simple formula. Based on this principle only, whatever the implements we are using now in industry, a hydraulic press, this hydraulic, suppose we are operating the pump with our normal available manual effort, this hydraulic press can press up to even 500 tons or 1000 tons also. How this heavy force is being obtained? Because of this hydraulic system. And the hydraulic jog, what we used to lift the machines. And also same formula is applied to create a resistance in the moving object, that is braking the moving wheels in the automobile. Hydraulic pressure is created here, that is opposite force to the moving one. That is how the Pascal's law is used in the fluid mechanics. Same principle only hydraulic excavator also works. Hydraulic excavator, how it works? All the implements in the hydraulic system works with the pressure transmission through the hydraulic fluid. How the pressure is transmitted, how the pressure is created, how the pressure is diverted, that will be discussed. If fluid is coming this direction, cylinder is moved outwards. If the fluid is coming this direction, cylinder is moved inside. Now let us discuss about the few critical components of the hydraulic excavator. First of all, there will be a prime mover, maybe engine or electric motor, whatever may be, which is the power source to supply the pressurized fluid in the required quantity with the required pressure. Then after the engine, the other important component will be hydraulic pump, main pump. Majority of the excavators, 99% of the excavators are equipped with the axial piston pump. The one what I have shown here is the gear pump. This is the axial piston pump. Precisely speaking, this is variable displacement axial piston pump used in the hydraulic excavators. Why? Because the gear pumps is a constant displacement pump. There will not be any variation in the flow. Whereas this variable displacement axial piston pump will be having the variation in the flow. As per the machine's requirement, flow will be varying and pressure also will be varying. How it functions, we'll discuss. This is how the pump animation looks like this. It will be having multiple pistons located in a radial block. Okay, when one side of this block is moving, the pistons will be moving in these barrels to and fro. So when they move backward, the vacuum is created, oil is drawn here. Then when they come again forward, the oil is pumped out. Oil is sucked from here, then oil is pumped like this. So this is the pump, a device which supplies the pressurized fluid with the required pressure and required volume to the implements of the machine. Then the hydraulic motor. This is the fixed displacement axial piston motor. Motor construction also is identical to the axial piston pump. The function is reversible because here it is sucking the oil and delivering the oil with the pressure. Whereas here oil from external source will go and push these pistons, so that when the piston starts moving in and out, because of this construction design, angular construction design, these blocks starts rotating. This is nothing but the output shaft of the motor. Precisely speaking, this is the reverse function of the hydraulic pump. Engine is over, pump is over, motor is over. The next component will be control valve. A control valve is a device where always oil will be available. This is the red one, is the pressurized oil coming from this pump available here. If there is no any work is required, oil will be just flowing back to the tank. If we want to supply the oil to any of the implement, the valve will be moved like this and oil from this will be going through this passage and going to the cylinder. If you want to move, it will be going and going back like this. This is how the control valve will functions. Then another component is called the pressure regulator valve, which is just fitted, it's a pressure regulator valve which is fitted after the main pump. The purpose or the job of this pressure regulator is to regulate the fluid pressure as per the design parameters. For example, an excavator is designed to work at 300 bar or 300 kgs per cm square. This valve regulates that pressure. It will not allow beyond 300 degrees, this thing and all, 300 degrees. So This job of this pressure regulator valve is to maintain the required pressure in the system. Okay. Whenever the pressure is exceeded beyond the limits, the pressure is released through this valve. Another component of the hydraulic system is the solenoid valve. We discussed about this control valve. There is another device to operate, that is to push or pull this spool. This is called spool. The moving one is the spool. This is the block. These are the oil passages. So there should be a device to actuate the spool to move forward and reverse as per our requirement. Okay. The device is called the solenoid. This is electronic solenoid, works with the DC power available in the machine. The amount of travel of this spool is decided by the amount of current passed through this solenoid valve. This is solenoid valve. Another valve in the system is called the check valve, which allows the oil only in one direction and restricts in the opposite direction. Oil is just flowing from left to right, but whenever it wants to come back, it cannot come back, because if it wants to travel in this direction, it is closed here. This is the check valve. The other component is the accumulator. The job of the accumulator, when the machine is running, it takes all kinds of shocks or vibrations in the fluid system. It avoids the jerky operation. It acts as a cushioning agent. The other job is it stores energy for a few minutes or few seconds. Suppose the machine is stopped by any chance, engine is stopped, still there will be some pressure is available at the system to keep the implements in safe position. The construction of accumulator looks like this. The blue portion is the charged nitrogen gas with some pressure. The yellow portion is the oil. In between this thing is the diaphragm. Okay. Always the pressure is available here. Whenever the machine is stopped on any account, unforeseen incident, whatever the pressure is available in this accumulator charged nitrogen, that will be used to bring the implements to the neutral position. Then the main components comes to, so far we discussed about where the fluid pressure is generated and how the flow is diverted depending upon the machine requirement. Now let us move the one actuators. The actuators means which actuate the implements of the machines, that is boom, stick or bucket. Those are cylinders. Let us discuss about few types of cylinders. This is the single acting cylinder, means it moves only in one direction with the pressure. Okay. The second, to return back, actually there is no any hydraulic pressure is required. It will come back on its own spring pressure. Clear examples are the jocks used in the industry and automobile. We will pump the jocks only during the rising, but when we release the pressure, the jock's piston comes back automatically back. So this is the single acting cylinder. Pressure port means the oil supply port coming. This is the piston. These are the piston seals, the black one. This is the piston rod and supported with the spring. Suppose we pump the oil from here. The oil pressure pushes this piston, making this complete rod travel outside, compressing this piston, because always pressure is stored here again. The moment the job is over, you release the oil pressure here or stop the oil pressure. Because the stored energy in the spring, the piston will be pushed back. The oil is coming here when the valve is open, traveling and pushing this. And because of its spring pressure, again it is coming back. The next is the double acting cylinders, which are used in the hydraulic excavators for all the implements. This is the cylinder having two ports. Pump flow written here this is the case number 1 of a double acting cylinder. This is the cylinder barrel. This is the piston rod. This is the piston. Pump flow is coming from this port, acting on this piston, making the rod to extend or travel outwards. and the return oil will come through this port and go to the tank. But when you apply the oil pressure in this port, it is acting back side of the piston or other direction of the piston, pushing this piston inwards of the cylinder. So the rod travels inside, and whatever is oil is available at this other side will be traveled back to the tank. This is the double acting cylinder. How the double acting cylinder works? This is the animation. The dark one is the pressure, the light one is the return oil. Coming, pushing here, coming, pushing here, going back. This is about the hydraulic cylinders. So we discussed about some critical parts of the hydraulic excavator. Now let us discuss about their location. The first one is the engine, which is available here, fitted here. There is the engine which moves which rotates the hydraulic pump. This is the hydraulic pump which generates the flow with the pressure of the fluid, and the fluid is passed from here to the control valve. There is no necessity of moving any implement. Oil coming from this pump flows through control valve and return back to the pump through the sump or the reservoir. Control valve is over. Now the cylinders connected to the bucket, connected to the boom, connected to the stick. These are the travel motors, both left side and right side, which are used to move the machines forward and reverse. This is the swing motor, which is used to swing the machine to 360 degrees. This is the motor, this is the gearbox. Here these are the motor, this is the gearbox. These are motors are connected to the gearboxes as discussed. Next, how it functions, we will say. Engine is rotated, then the pump rotates simultaneously because the pump is directly coupled to the engine. Oil is delivered with the pressure and volume. It goes to the control valve. If no implement is working, it returns back to the pump through the sump or through the filter, whatever is provided. Then, if at all you want to actuate one of these cylinders, either boom or stick or bucket or two or three simultaneously, so the signal will be given to this respective valve and passage is opened. Oil whatever is available here will be passed through these cylinders. If you want to extend, oil will go from in this direction, the piston is extended. If you want to retract the piston, the oil again, the direction is changed through these solenoid valves and it is applied here and the piston is retracted. Same if you want to swing the machine, oil pressure is applied on this motor. Motor rotates, gearbox rotates, the pinion rotates, and the upper structure rotates over the base. If you want to move the machines, these motors rotates. The travel gearbox also rotates, track chains also rotates. If you want to steer the machine, turn the machine left or right, you have to give more flow to the one of the motor and less flow to the other motor. So the turning takes place. We discussed in the steering system of the vehicles. The steering happens whenever we create the differential speeds between the two wheels. Then let us also go through some of the symbols of the hydraulic circuit which are essential to understand the flow diagrams or circuit diagrams. This symbol indicates the hydraulic pump. See, this arrow is going out of the circle and the arrow which is coming inside the circle is the motor, that is the motor oil is coming inside, and this empty triangle indicates the air and this is the air motor, and this M indicates the electric motor, and pump same symbol. Here it is single acting cylinder with one inlet port, and this is the rod, piston and barrel. Single acting cylinder with a spring return means which comes back with the pressure of the spring, indicates like this. Single acting cylinder with spring advance. The difference between this thing is always the piston is in retracted position. When the oil is applied, the piston rod is extended against the spring tension and it will be returned back with the spring pressure. Whereas in this case, always the Piston is in extended position with this spring force. When the oil is applied here, the piston travels inside, and when the oil pressure is released, again it is extended outwards. So it is with the spring advance. Then two ports on the cylinder is the double acting. This indicates the connected. This indicates the non-connected, and this envelope normally open, normally closed. These are the various symbols. This is two-way valve, this is a three-way valve, the four-way valve like that. Some more symbols like this. These are the accumulators. Generic accumulator, this is a gas, the spring accumulator, all these things. Cooler, or the heater, separator, check valve, this is the filter. This indicates the oil returning to the tank. Go through the symbols, further more symbols if you browse the in internet. Understanding the symbol is very essential to understand the hydraulic schematics of any machine. Go through these 2 pages notes. In case you have any queries, you can always contact.